when they take in water, it all goes to their vacuole, and their vacuole will swell up like a big balloon, and it pushes up against the cell wall, and it makes the cell what we call turgid. Okay, turgid. That just means like very rigid. But it doesn't burst because that cell wall is rigid and it's able to keep that cell from bursting. So like when you go to the grocery store, have you ever noticed that they spray water on the salads and the vegetables? The reason for that is they want their plants to look turgid. That's what a fresh plant looks like. Okay? Whereas if you have a salad and you put salad dressing on it and you leave it for a while, what happens to that lettuce? It gets what we call soggy or wilted because its vacuole has lost water. It has been placed in a hypertonic environment because that salad dressing is very salty, which causes the vacuole to lose water, and then the cell is no longer turgid. It now is what we call, it's flaccid, it's shrinking, it's shriveled, it's wilted, and that doesn't look fresh, and that doesn't look good, and that doesn't look like something you want to eat. So the way that those grocery stores get around that is they constantly spray their lettuce with water so that their plants look fresh, and you will want to buy them. Okay. All right. So who would like to volunteer to read the next paragraph? We're going to do the same thing as they read and shout out your annotation.
One reader.
Who wants to read?
Kalijah.
Yay, come on, Kalijah. Come on, Kalijah, let's go. Appreciate you. Thank you, Capria.
You can't read.
That's not cool to me, but quiet. So as Capria's reading, what are you doing? Shouting out whatever annotation you put. Alright, come on, Capria.
Small molecules can pass through the plasma membrane process called diffusion. Diffusion is the movement of molecules in an area where there is a higher concentration of a large amount of the substance to an area where there is a lower concentration, lower amount of the substance. The amount of a substance is the relation to the total volume is the concentration. During diffusion, molecules are said to slow down their concentration, flowing from an area of high concentration to an area of low concentration. Molecules slowing down a concentration gradient is a natural process and does not require energy. Diffusion, along with facilitated
concentration gradient.
diffusion with the help of channel substance and osmosis are all examples of.
Hold on, let's back up, because I think I got lost. So can you start, I think we said we want to put a plus sign, where it says it does not require energy, okay? Now start back with diffusion. Again, if there's something that we already went over, we need to be putting plus signs over things that we already know. Okay, things that are important, we need to make sure we put an exclamation point. So start with diffusion. Capria.
Diffusion, along with facilitated diffusion. Diffusion with the help of channel protein and osmosis are all examples of passive transport.
Good. Okay, you can keep going.
Diffusion can occur across a semi-permeable membrane.
Semi-permeable.
Semi-permeable membrane, such as the cell membrane, as long as the concentration varies. Molecules will continue to flow in this manner until
Equilibrium.
At equilibrium, there is no longer an area of high concentration or low concentration. And molecules flow equally in both directions across the semi-permeable membrane. At equilibrium, equal amounts of a molecule are entering and leaving the cell. Underlying.
Good. Alright, so there was a lot of things that we already knew in this test because we already learned about it when we did our intro last class. Okay, so what were some of the things that you already knew?
Semi-permeable.
You knew that the cell membrane is semi-permeable. What was something else that you already knew?
Passive.
Say it louder.
Passive transport.
Passive transport. What did you know about passive transport? It does not require energy. Good. What is something else that you knew?
Facilitated.
A what? Okay, the plasma membrane. We already said that. Plasma membrane is semi-permeable. Passive transport does not require energy. What about the concentration gradient? Did we know about the concentration gradient already? That diffusion is a concentration gradient from what to what? High to low. So that's something that we already knew. Okay, we saw a repeat of a lot of words. They're coming up over and over again. And so most of this stuff, I don't see any question marks. I don't see any question marks. So it's things that we kind of already understand. Okay, so we're just talking about diffusion and how molecules move from a place where they're highly concentrated to a place where there's a low concentration. So this picture is really good at kind of getting you to understand the process of diffusion and also the end goal of diffusion. Okay, so what is looking at this picture? What does it seem like is the end goal of diffusion?
Equal.
Huh?
Equal.
Equal on both sides. And what is the vocab word that we learned that means equal on both sides?
Isotonic.
Well, isotonic, yeah, that does mean equal on both sides. But there's another word that we learned. Equilibrium. Good. So when two solutions are both isotonic to each other, they're in equilibrium. And that is the goal of diffusion. The goal, so when we talk about an isotonic solution, we're talking about osmosis. So in osmosis, when eventually the water concentrations are equal on both sides, we call that also isotonic. But when we're just talking about any solute, and we're referring to diffusion, then when it's equal on both sides, we refer to that as equilibrium. Okay? Great job, guys. Alright, so I want us to go on to the summary review questions that are at the bottom of the page. What would happen to a freshwater fish in the ocean? Please explain.
They're gonna
Okay.
die.
So let us discuss that. What do you think is going to happen to a freshwater fish in the
It's
ocean?
gonna die.
It's going to die. So in the initial paragraph, we learned about what's going to happen to a saltwater fish in freshwater. What happened to the saltwater fish in freshwater?
It's gonna live because it's salt.
It's
I
so
mean,
when
It
that
got something to do with salt.
okay.
Yeah, salt.
So when that saltwater fish was placed in freshwater, its cells swell up and it died. Right? So now we got the opposite situation. So what do you think is going to happen to this fish? I know it's a really ugly fish. Okay, so we have this fish, and it is a freshwater fish. So inside of it, remember, when an animal lives in this environment, it needs to be isotonic to that environment. So if it's a freshwater fish, what do you think's inside of it?
It's gonna hold.
Fresh water. So is fresh water hypotonic or hypertonic, Kalijah?
Hypo.
Huh? Hypotonic. So inside of the fish is a hypotonic environment. Okay, let's review what hypotonic means. Does that mean low solute or more solute?
Lower.
Low solute. Okay? And if there's low solute, do you think there's going to be more or less water?
More water.
More water. Okay, so low solute means more water. Okay? So now the salt water, on the other hand, the salt water, do you think that's going to be hypotonic or hypertonic? Hypertonic. So the salt water is hypertonic. Does that mean more or less solute?
Less.
More.
Yeah,
more solute. Okay,
more.
what about water?
Less water.
Less water.
Less water. Yeah,
Okay.
I'm trying to say.
So what's the process that's going to happen here when we have a concentration gradient?
It's going to mix.
What is that process called? So it's either going to be osmosis or diffusion. Here we're talking about water. We have a concentration gradient, so which one's going to happen? Osmosis is going to happen. Okay? So osmosis is going to happen. Let's write that word down. Okay. So in osmosis, what is osmosis exactly?
You said what?
What is osmosis?
Osmosis is the I'm just playing, but the first, how you say that word?
Diffusion.
The diffusion of water across a membrane because of the difference in concentration.
So we have a difference in concentration. Osmosis is going to happen. So diffusion of water. Diffusion is that high to low or low to high? High to low. So water is going to move from where there's more water to where there's less water. So what direction is the water going to move?
Hypertonic. I mean, like what you mean?
Out of the fish cells or into the fish cells?
Out.
It's going from where there's more water to where there's less water. So we're gonna want to draw an arrow from where there's more water to where there's less water. Is there more water inside the fish?
Yes.
Yes. So we're gonna draw going out of the fish. Okay? More water to less water. So water moves outside of the fish. What's gonna happen to the or outside of the fish cells? Because we really are talking about cells. I drew a picture of a fish, but we're talking about its cells. So it's moving outside of the fish cells. What's gonna happen to the fish cells? They're gonna shrink and shrivel. Okay, so now we need to put that into words. So I want you to go ahead and put what we just talked about into words. Into a complete sentence. And then I want somebody to do it.
Recording this.
From Miss Jallow.
Focus on putting your sentence together. Focus on putting your sentence together. You're not even done asking me to come with yours and watch you write. How about you people want to share?
No. How about now?
Alright, so for the sake of time, can somebody that has their sentence written, can you please share out?
Oh, excuse me.
Who would like to share out?
The fish cells are going to shrink because of the low hypertonic. The hypertonic. I don't know.
You're on the right track. So to make it simple, let's use the word osmosis in our response. Let's use the word shrink and shrivel. And we need to talk about water, whether it's leaving the cell or entering the cell. So I'll start you off. The fresh water fish, the fresh water will leave the cells through, what should I put?
The cells through
Osmosis.
osmosis, yeah.
Causing, what should I put?
Hypertonic.
The fish cells to shrink and shrivel.
Good job.
And then Martravius, what's going to happen to the fish?
They're gonna die.
It's going to die. And the fish will die. Alright, perfect. So now number 2, you don't have to have my exact response. If your response has those words in it, it means the same thing. Okay? So now for number 2, we're going to compare and contrast the 3 types of passive transport. So what we're going to do is we're just going to make 4 columns, okay? What are the 3 types of passive transport? Okay, diffusion. What's the other one that sounds like diffusion but has help? Facilitated diffusion. Active transport is not a type of passive transport. That's a different type of transport that includes endocytosis, exocytosis.
Osmosis.
Osmosis. Awesome. And then we're going to have a column for what they all have in common. Okay? Alright, so let's first talk about what they have in common. What do they all 3 have in common?
They don't require energy.
They're all passive transport. What else? How do molecules move? With or against their gradient, their concentration gradient? With. Alright, let me put move. Move with concentration gradient. Alright, and if they move with their concentration gradient, is this low to high, high to low?
High to low.
High to low. Okay? Alright, so those are some things that they have in common. Now what is osmosis specifically? Well, it's not just when water exits the cell, because water can exit the cell or it can enter the cell. The diffusion of water. Okay, and it's specifically, all of these are diffusion because diffusion is when we go from high to low. This is the definition of diffusion, when we go from high to low. So all of these are diffusion, it's just that osmosis is specific.